Good day, everybody. Once again, we are back together, and this time we are studying our series on trigonometry. I'm really excited to start on this one. It's been a while, and I've been getting quite a lot of comments of people, asking us to start with that, including geometry, and which we will get to probably in our next series. All right, so for those of you who are new to the channel, please just subscribe. Hit that subscribe button. Yes, do it now. All right, and the notification bell as well, so that you are reminded every time we are posting a new lesson. And of course, for those of you who need assistance with mathematics or physical science, our email address is info@mlungisi.co.za. All right, so let's get into the lesson. So in this case, we are going to be looking at the reduction formula. All right, so let's start here. So when we're talking about the reduction formula, first of all, let's just talk about general trigonometry. Obviously, we've got trig ratios. Okay, let's start here. We've got the sine of any angle. We know in this case, if we are given a triangle, let's just take any particular triangle. Okay, suppose this is our angle theta. Now, you've got an angle, or rather, you've got a side that is opposite, which means it's directly in front of the angle. Okay, we call this the opposite side. Okay, and we've got the adjacent side, meaning adjacent just simply means next to. Okay, so this is next to the angle. And of course, there are two sides that are next to the angle. It's, of course, this one here in red, and the other one in yellow. Okay, I wanted to pick yellow. All right, so the other one in yellow. But we actually have a special one for the yellow one, and we call that the hypotenuse. Okay, so just keep in mind that we've got this side here, the red one, the adjacent side, meaning it's next to the angle, and the other one, which is the hypotenuse. Now, when we talk about the sine of the angle, okay, so let me just go back to that. So when we talk about the sine of the angle, this is always going to be the opposite side. So it's basically just a ratio. Okay, so it's opposite over hypotenuse. Okay, and of course, we've got the cos of an angle. All right, this is going to be the adjacent side over the hypotenuse. I'm going to relate it to trigonometry in just a few. Of course, we've already done that, but in terms of mathematics. And then the tan of the angle, which is going to be opposite, the opposite side divided by the adjacent side. So what you're looking at is just a ratio of relating two sides of a triangle. Okay, and in this case, we use those trigonometric ratios. Okay, so having said that, now we use what we call the Cartesian plane. All right, we use the Cartesian plane, and in the Cartesian plane, we usually start from 0 degrees here, and we measure an angle. Now, please, I want you to listen carefully. We measure it clockwise. Okay, we measure any angle clockwise, so meaning we're going in that direction. Okay, right, so according to that circle there. Right, so then this becomes 0 degrees, and that's 90 degrees. Okay, that's 180 degrees, and that's 270 degrees, and obviously, therefore, that becomes 360 degrees. Right, now, obviously, because we are measuring clockwise. Now, you can also measure an angle anti-clockwise. However, once you go anti-clockwise, what happens is that then the angle becomes negative. So in this case, that would be 0 over there. Okay, and then you go anti-clockwise. Now 270 becomes minus 90, and 180 becomes minus 180, and 90 degrees becomes minus 270, and 360 still becomes negative 360 as well. So in a sense, this is what our Cartesian plane looks like. Now, if we have to consider taking an angle, all right, we say, well, we can take a reference angle from anywhere. All right. We just consider taking a reference angle anywhere. Now, there's something that we should always keep in mind. Okay. Right. If we ever take the ratio of sine, remember that our Cartesian plane is also the y and the x-axis. Now, what you'll notice is that if I start, for instance, in the first quadrant, both y and x are positive. So in this case, my y is positive, but my x is also positive. So in this case, both y and x are positive. So if I were to take a triangle here in the first quadrant and say, well, let that be my angle theta. So in that case, you'd see that we would have both x, so whatever the value of that, let me make it red. Okay, so this value here, so whatever x value you'd have there would be positive, but also, okay, let me make y yellow. So, but also your y value would also be positive because it's going in the positive y axis, right? It's going up. Then obviously, whenever we take the value of r, what is r in this case? That would be a hypotenuse. Let me make that in blue. Okay, so in that case, when we take the hypotenuse, therefore the hypotenuse would be actually, it would always be positive. So if I take the ratio of opposite, let's say opposite over hypotenuse, the sine of theta, my opposite side, okay, which is the yellow side, okay, which is also, we can say that's y because that's the y value, all right. So my y value is positive over hypotenuse. My hypotenuse, which is the blue side, is also positive. So that makes sine in the first quadrant to be positive, okay. So the sine of the angle in the first quadrant would be positive. All right, now, of course, we can do that for any of them. Now, if you go to the second quadrant, now I want you to please note, by the way, that opposite and adjacent side, we can also use x. So we can use x here. We can say that's y, and for the blue side, we can say that's r. Now, you keep that in mind. So which means, just going back, all right, we can also say that sine of theta is y over r, okay? And then cos of theta, that would be x over r, okay, because the adjacent side is the x side, okay, and the hypotenuse is r. And then obviously then the tan of theta is y over x. Now, whichever one you prefer, that would be the one that you should adopt, okay? Whether this generic one or the one that has to do with y and x, it really doesn't matter. Right, now, quickly let's get into it because I want to try and get to as many examples as we possibly can. So I want you to please note, if we were to go, for instance, in the second quadrant, okay, so if we go in the second quadrant and we draw a triangle there, I want you to please note what happens suddenly in the second quadrant. You'll see that your x value is now negative. Can you see? So in that case, my x is negative, but my y is still positive. So I would have a positive y value there. So my y would still be positive. And in that case, remember, r, we said, is always positive. And you always get the r value, by taking using Pythagoras, rather. Okay, right. Now, perhaps I want to just draw another Cartesian plane that just looks nice and plain. Right, so now I want you to please note the following. Remember, we said this is 0. We said this is 90. We said this is 180. And this is 270. So when we use the reduction formula, okay, we will actually be trying to reduce any angle into an acute angle, okay? So by using what we know here. Right, now we know that sine, we use what we call the cast diagram. So in this case, I'm going to just quickly use that there. Okay, let's make that nice and yellow. So our cast diagram simply says C, A, S, and T. So our cast starts here at the bottom, right? So cast diagram says C, A, S, and T. What does that mean? It simply means that only cos is positive in the fourth quadrant, which is over here. Why? Because both y and x are both negative. So as a result, not y and x rather, x and r are positive, and cos is x over r. So in this case, only cos is positive here. In the first quadrant, all of them are positive. Okay, cos, sine, and tan, and they are co-ratios as well, co-functions. Okay, they are also positive. In the second quadrant, we know it's going to be sine, okay, and its co-function that are positive. And in the third quadrant, tan and its co-function are positive. What does that mean? It simply means if I'm going to take the tan of any angle in the second quadrant, it's going to be negative. Okay, if I'm going to take the cos of any angle in the second quadrant, is going to be negative. It's only sine that is positive. Okay, right, now quickly just to find application in this, because I want us to really go into the application. Now we know here this would be our angle theta. Okay, so we consider theta to be an angle in the first quadrant. Okay, now what is in the second quadrant? We know this is going to be, now anytime we've got an angle that is 180 minus theta, remember we consider theta to be an angle that is in the first quadrant. So here we've got 180 minus theta. But please also note, perhaps it would be a good time to also include that this would also be 90 plus theta. Okay, right, and then in the third quadrant, I know I've got 180. Think about it. So if I take an angle and I say, well, 180 plus theta, if theta is an acute angle, then 180 plus theta gives me an angle that would be in the third quadrant. Okay, but also please just note this can also be 100, or rather 270 minus theta. Okay, right, we're going to talk about these special ones here in just a bit. And then obviously here we've got 360 minus theta. Okay, and by the way, you can also go the other way, anti-clockwise as well. I'll just show you in just a bit. Okay, so this is 360 plus theta minus theta, but as well it is 270 plus theta. Okay, I hope that makes sense to you. Of course, now taking this anti-clockwise, you can say, well, this is minus theta. Okay, so now obviously when we remember, this is going to be minus 90. Okay, so this would be the same as minus 90 minus theta. Okay, so you can do that for going the other way around. All right, now what I want us to do in the next few seconds is we're going to just look at an application of all of this. All right, and then take a few examples. All right, so now having to look at just a few things. All right, so I wrote this prior so that we could just try and save some time. So in this case, when we look at sine of theta, of course, cos of theta and tan of theta, all of those are positive, and nothing changes about that. So it means that sine of theta is equal to sine of theta. So nothing changes about all of those ratios. Okay, so sine of theta is sine of theta. It just remains that because all of them are positive. Cos of theta remains exactly that, the cos of theta, because all of them are positive, and that becomes also tan of theta. Now, the trick now becomes when we go to the other quadrants. Let's go to the second quadrant. So if I say sine of 180 minus theta, so that means this is in the second quadrant. How is sine in the second quadrant? Well, that tells me in the second quadrant sine is positive. So as a result, that would still remain positive sine of theta. Remember, we said we are trying to reduce all the angles or the ratios into expressions where we've got the angle to be in the first quadrant. So sine of 180 minus theta will be equal to sine of theta. So the cos of 180 minus theta, you can see. So the question will be, how is cos in the second quadrant? Okay, you'll say, well, only sine is positive in the second quadrant. So meaning cos is negative. So this will be minus the cos of theta. You see how the reduction formula works, right? And tan of 180 minus theta, you'll say to me, well, how is tan in the second quadrant? You'll say, well, tan is negative because only sine is positive in the second quadrant. So that will become minus the tan of theta. I hope you're getting the the gist of what we're trying to say, right? So let's go to the third one. Okay, so in this case, what happens if I've got sine of 180 plus theta? So when I've got sine of 180 plus theta, that's in the third quadrant. So you'll say, well, but in the third quadrant, I know that only tan is positive. So it means that would now become minus the sine of angle theta. So we've reduced that angle into an angle in the first quadrant. And then cos of 180 plus theta, of course, that should also be minus the cos of theta because only tan is positive in the third quadrant rather. But then tan of 180 plus theta therefore will become positive tan of theta. Okay, right, you don't need to memorize all of this. You just need to remember that cast diagram. Okay, remember which are positive in which quadrant, and that's it. Okay, so sine of 360 minus theta, I hope I'm not wasting any more time. Okay, so this is going to be sine in the fourth quadrant is negative, so this will be minus the sine of theta. Okay, and cos of 360, right? Cos is positive in the fourth quadrant. You can see that. Okay, so this will be cos of theta. Okay, and tan of 360 minus theta, that will obviously be minus the tan of theta. Now, just quickly, I wanted to also, just find ways of expressing 90 minus theta. Now, please, I want you to hear me out carefully. So we know 90 minus theta is in the first quadrant, but the moment we say 90 minus theta, I wish I could just show you why that is the case, but I don't want to make this lesson too long. But remember that once we have 90 and 270, okay, just keep that in mind. We do that for both 90 degrees and 270 degrees, but I'm just going to illustrate it with 90 degrees for now. Okay, so 90 minus theta, they now change to their co-functions, or their co-ratios rather, in this case, and the co-ratio of sine is cosine. Okay, all right, so in this case, sine of 90 minus theta, because they are all positive, that becomes cos of theta. All right, and then cos of 90 minus theta, because they are all positive in the first quadrant, that becomes sine of theta. Okay, so the co-ratio of sine is cos, and the co-ratio of cos is sine. Okay, so they are co-ratios of each other. Right, and then tan of 90 minus theta becomes cot. Okay, we don't use this much, to be quite honest, but yeah, I want you to know it does exist. The co-ratio of tan is cotangent, which is cot. Okay, so that would be cot of theta. All right, Now, please, I want you to note how we're going to do it for this one. So again, sine of 90 minus theta. Yes, it will change into its co-ratio. However, I need to find out how is sine in the second quadrant. Remember, once we say 90 minus theta, that's in the second quadrant. Now, I'll ask myself, how is sine in the second quadrant? You'll say to me, well, in our cast diagram, I know that sine is positive in the second quadrant, so that will become positive cos of theta. Okay, right? It changes into its co-ratio. Okay, and now let's do the one for cos 90 minus theta. You'll say, well, cos 90 minus theta, how is cos in the second quadrant? Okay, well, cos is negative, only sine is positive. So in this case, it will be minus the sine of theta. So first of all, the minus comes from the fact that cos is negative there in the second quadrant. Now 90 minus theta, remember we need to change to the co-ratio, and the co-ratio of cos is sine. And then the tangent of 90 plus theta, again, 90 plus theta, 10 is negative, okay? So in this case, it changes to its co-ratio, which is going to be cot of theta. Okay, as I did say, maybe let me just illustrate it with just one. If I said the sine of 270, for argument's sake, minus theta, right? So if I have 270 minus theta, then again, I'm going to do the very same thing. 270 minus theta, that's in the third quadrant. How is sine in the third quadrant? It's negative, okay? Remember, only 10 is positive there, so it's negative. But now I'm going to change to the co-ratio, so this will become minus the cos of angle theta. I hope that makes sense. Okay, right. So without any further ado, ladies and gents, what I want to do, just do a couple of examples and we will conclude our lesson. All right, so let's take our first example. Right, so we've got sine of 180 minus theta, cos of 360 minus theta. Let me just fix that. Okay, and 10 of 360 plus theta, and all of that divided by sine of theta minus 180. The interesting one is this one, and I want to get to that so that I'll show you how to solve it. Right, so sine of 180 minus theta. All right, let's start there. So how is sine? This is definitely in the second quadrant. So how is sine in the second quadrant? Okay, let me just draw a little bit of our cast diagram there. Cast, okay, sorry about that. Right, so our cast diagram, that's what it looks like. So we know sine in the second quadrant would be positive, so that would still remain as sine of theta, multiplied by cos of 360 minus theta. Remember, 360 minus theta, that's in the fourth quadrant. Cos is positive there, so that would be cos of theta. Okay, multiplied by the 10 of 360 plus theta. Now think about it, 360 plus theta. In this case, if we have 0 here, 180, 90 rather. So that's 90. So that would be 90. That's 180, 270, and 360 over there. Now, if you say 360 plus, so that would still be in the first quadrant. So in this case, that would still be 10 of theta. So as a result, and remember the Cartesian plane repeats at every 360-degree cycle. So in this case, this would still be the 10 of theta. Okay, and then divide all of that. Now, I want to get to this bottom one here because, once we have the angle minus something, then it requires us to now go the opposite direction. But I want to just show you a quick way in which you can do that. Whenever you've got a negative angle, or when you've got something that doesn't look like what we quite normally are used to, Okay, so what you can do is you can express that as sine of. Now I'm going to take a different bracket, so open up a different bracket there. Would you agree with me? That would still be, now I'm putting a negative there, and this would be the same as minus, okay, minus theta, sorry, minus 180 minus theta. Okay, so I'm changing it around. I wanted to write this in a different, right. So this would be the same. So I haven't changed anything because negative 180 times, negative times a positive there, that would still give me minus 180. And negative times a negative theta would still give me positive theta. So I haven't changed anything about that there. Right? Okay, so the top remains as is. So that's going to be the sine of theta, the cos of theta, and the tan of theta divided by. Now I've got a negative angle inside of here. Whenever we've got a negative angle, just simply add 360. So this would be the sine of. Now note, I'm going to say this is 360 minus my yellow bracket. Okay, so that would be 360 minus 180 minus theta. Okay, so, and I close that white bracket in there. Right, so you can see that I'm trying to get to a point where this becomes what we are normally used to. So in fact, that now becomes sine of theta, cos of theta, tan of theta, okay, divided by, if you notice, now we've got 360 minus that. So whenever you've got a negative angle, you can just simply add 360 so that you try to normalize it to what we are used to. Okay, so if I say 360 minus that whole bracket, now think about it. What happens? Then it's 360 minus that 180. And now remember that we've got this negative and that negative there. Okay, so that's 360 minus 180. That becomes 180. Right, and a negative times a negative, that gives us a positive. This is plus theta. You can see how that would be in the third quadrant, isn't it? And how is sine in the third quadrant? It's going to be a negative. Remember, only 10 is positive there. All right, I hope what I've explained makes sense. Okay, so that would be sine of theta, cos of theta. I'm just dragging this now, divided by, now sine of 180 minus theta, now that becomes negative sine of theta, because sine is negative in the third quadrant. Okay, so what does that do? We now get rid of that there. Okay, remember now we're left with negative 1. So now we're left with minus the cos of theta multiplied by the tan of theta. Now remember, when it comes to trigonometry, you know what always works is to always try and change any ratio into sine and cos, right? So I know I haven't taught this as yet, but I'm sure many of you know it. Okay, cos of theta, I know I can change tan into sine theta over cos of theta. Oh, I almost dropped that negative there. Please remember, we have that negative there. So this would be minus the cos that comes from that minus 1 that was there. Okay, so right, what happens? Of course, those two cancel out. And what do we have left? This is minus the sine of theta. Okay, and that is how we would have simplified that particular example. All right, let's take one last example and in this case, wrap up our lesson. All right, now our second example looks as follows. And of course, again, just to draw a little Cartesian plane there, just so that we know what we are doing. And we write there cast. Okay, just to remind ourselves. Right, now we've got the cos of minus theta. Okay, and remember we said that would be in the fourth quadrant, but just to remind you again, whenever you've got a negative angle, right, just always add 360 to it. So this can easily be 360 minus theta, so that you try to normalize it as much as possible. Right, so that's cos of 360 minus theta, right? So in this case, we've got multiplied by 10 of 180 plus theta. 180 plus theta, that's in the third quadrant, so that tells us 10 is positive there. Okay, so I'll say multiplied by 10 of theta, multiplied by, we've got 10 of theta minus 360. As I said, when they've expressed it with negative angles, so what I can do is that I can add 360 to that, and it would still be the same thing, right? So I can say, well, this is 10 of, now I'm going to take a bigger bracket, a square bracket there. This would be, all right, 360, okay, plus theta minus 360. Okay, so I haven't changed anything. We've just added. Remember, everything repeats after every 360 cycle. I wrote 0 there instead of theta. Okay, so that would be theta minus 360. Okay, so divide all of that by cos of 180 plus theta. Remember, cos 180 plus theta, that's in the third quadrant. Cos is negative there, so that would be cos of, minus rather, the cos of theta. And 10, I've got minus theta there, so we can change that to 360. 360 minus theta. Remember, once you add 360, you really have not changed anything. Okay. Right, you can add or subtract 360 depending on the particular example. Right, now let's try and simplify this for ourselves. So this is cos of 360 minus theta. Okay, so cos 360 minus theta, that's in the fourth quadrant, and cos there is positive, so this would be the same as cos of theta. Okay, multiplied by 10 of theta. Okay, and if you notice, you've got 360 minus 360 there. Okay, positive times a negative would be a negative. Would be a negative rather. So you've got 360 minus 360, which would be theta, would give us theta. So this would be the same as 10 of theta. And by the way, 10 is positive in the first quadrant. So you end up with 10 of theta, and you divide that. Minus cos of theta. Okay, and the last one, you've got 10 of 360 minus theta, and remember, 10 is negative in that fourth quadrant rather. So in this case, that would become multiplied by a negative 10 of theta. Okay, so now let's cancel out anything that we can. We know negative times a negative at the bottom there. Okay, that becomes a positive. Okay, so in this case, that cancels with that. Okay, and cos cancels with cos. All right, and we've got negative times a negative becomes a positive. And so as a result, what is our final answer? It would be positive 10 of theta. Right, ladies and gents, I think I want to kind of leave it there. All right, I hope that you were able to just follow on that reduction formula. Hopefully, most of you are going to be able to get all the questions right. And if you haven't subscribed or if you haven't considered subscribing, hopefully this will convince you. Okay, hopefully you enjoyed that lesson. And by the way, just please tell as many people, share, like. Okay, if you liked this lesson, just hit that like button. Okay, so that we can get that algorithm going. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.